Okay guys, so today we're going to be talking about plate boundaries, and I want you, as I'm going through this, to fill out your little half sheet of paper that you have. It looks like this-ish, like that. Okay, so I'm going to give you a plate boundary. I want you to make a little picture. I want you to describe it, give what landform it makes, and then put a real world example in there. So I'll show you kind of as we're going through. So, here we go. Here, oh my goodness. Okay, here's our 3 plate boundaries. Let's start with divergent. So a divergent boundary is where the plates move away from each other. They move apart. So on land, that would form a rift valley, and a real world example of that is East African Rift. So go ahead and pause this video, go back to your little sheet, describe what a divergent boundary is, tell me what landform does it make, and then give me that real world example, East African Rift, and then draw me a little diagram of 2 arrows moving apart. Okay, so then in water, that's known as seafloor spreading, which we've talked about, the seafloor spreading theory that Harry Hess came up with, and the landform that it makes is a mid-ocean ridge, and the biggest one, the most famous one, is the Mid-Atlantic Ridge, so that's your real world example. Okay, so you should have your whole little top part, your divergent boundary, filled out. And if you don't, pause the video, rewind, and get it all filled in. Okay, the next one, convergent boundary. There's actually 3 types of convergent boundaries, and this is on the back of your half sheet of paper. Okay, so the very first type of convergent boundary is where 2 continental plates come together to converge. So your little picture should have 2 arrows pointing at each other because they're moving towards each other, moving together. So 2 continental plates converge and they form mountains. So a real world example of that is the Himalayan mountains. Another type of convergent boundary is an oceanic and an oceanic plate. So remember, those are super dense, very thin but super dense. And what happens is older crust gets destroyed when it subducts or goes underneath the new crust. So in this little diagram here, you see 2 plates coming together, but one goes underneath the other one, and that crust goes down and it melts into hot magma and it gets destroyed. And then when it comes back up on the seafloor spreading side, then it turns into new rock. Okay, so this is a type of convergent boundary, oceanic, oceanic. One subducts underneath the other one. So when you draw your picture, you're just going to have one go down and one point towards it. Some examples of the landforms it makes is underwater volcanoes, island arcs, and trenches, and a real-world example is the Aleutian Islands. And then our last type of convergent boundary is an oceanic continental, so it's the 2 types of crust coming together. The more dense plate is going to go underneath, which is the oceanic. It's going to go underneath the continental, which is called subduction, and it creates volcanic mountains, some trenches. Some real-world examples are Mount St. Helens, the Andes Mountains, and the Peru-Chile Trench. So when you're drawing your picture here, you're also going to have another one subduct underneath. Okay, our last type of boundary is transform, or the sliding boundary. So they slide past each other, and the tension is so great when they slide past each other that it causes earthquakes. So that's your landform that it makes, earthquakes. And a real-world example is the San Andreas Fault. So the picture you're going to draw is 2 plates sliding past each other. Then give me a little description. Landforms are earthquakes, and real-world example, San Andreas Fault. Okay, so if I went too fast, or if you need to go back, go ahead and pause now and rewind and go to where you need to, and your whole notes should be filled out. Glue this in your journal and then get your project done.